The diagram shows triangle ABC. We're told that AB is 3.4 centimeters, which we can see here. AC is 6.2 centimeters. BC is 6.1 centimeters. D is the point on BC, such that the size of angle DAC is 2/5 multiplied by the size of angle BCA. And we need to use that information to calculate the length of DC, giving our answer correct to 3 significant figures and showing all of our working. Now for this we can use the cosine rule. This can be applied to the triangle in some way like this. So let's say we knew the angle A here. We can do the cos A part. And we knew the lengths B and C here. So the ones adjoining the angle. We could then work out this length here. So our equation is A squared at the subject. So that's in essence the cosine rule, and we can use that here. So I'm going to add some extra labels here because we've got A here, the angle A, capital A. So this side here, all of this, is going to be little a. Same with this one, it's going to be little b and little c. Now I'm going to work out this angle here. Now what's great with the cosine rule is we can actually switch the letters up a little bit. So I say, okay, I want to use angle C, so we're going to have cos C. So that means I'm going to have C squared here. I'm going to have a B squared plus A squared this time, minus 2BA. This is completely equivalent, we've just shifted it around to work with the letters on our diagram. So C squared, what's that on our diagram? That's going to be 3.4 squared equals B squared, 6.2 squared, plus A squared, which is going to be 6.1 squared, minus 2, B, which is 6.2, and A, which is 6.1. And that's going to be multiplied by cos of C, which is what we're trying to work out. We don't know that yet. And just pointing out that's cos of capital C, so the angle. It's a little bit confusing because both the C's look the same. So I'm going to use the calculator to work out the parts of this I can. So 3.4 squared is 11.56. If we do 6.2 squared plus 6.1 squared, we get 75.65. Now I'm going to do minus 2 multiplied by 6.2 multiplied by 6.1, but leave cos C how it is. So minus 2 multiplied by 6.2 multiplied by 6.1 is minus 75.64. And then we've still got our cos C on the end there. Now let's rearrange this so we get our unknown value, our cos C, on the left hand side. So we're going to add 75.64 cos C to both sides. Now subtracting 11.56 from both sides, leaving us with 64.09 on the right. And last but not least, if I divide both sides by 75.64, these cancel here, leaving us with cos C on the left hand side, equaling 64.09 divided by 75.64. Now I'm actually going to leave this as a fraction for the minute because it will make it a bit easier. Now we want to work out what the value of the angle C is. So if I do inverse cos of this fraction here, we get 32.08046913. That's fantastic. So we now know this angle up here, C, is approximately 32.08 degrees. Now that's actually the angle BCA. Now we can use the information here that the size of angle DAC is 2.5 multiplied by the size of angle BCA. So we're going to have the size of angle DAC equaling 2/5 multiplied by our 32.080 ... number. So if we work this out in our calculator, and it's great if you store this long number in the calculator, you can reuse it in the calculation to make it really accurate. We should get that equaling 12.83218765. So this angle here is approximately 12.83. Now we've got one more angle in this triangle that's unknown, so let's work that out. Now we know the sum of all the angles in a triangle is 180 degrees. The size of the angle ADC is going to be 180 minus both our other two angles. So 32.080 ... minus 12.832 ... And again, using the long numbers for these that we stored into the calculator, we should get 135.0876432. And we can now use the sine rule. So what we've got here is DC, so the length DC over sine of the angle DAC, equals AC over sine of the angle ADC. And we can see that if we look up at the diagram, because we've got this angle here, we're essentially saying DC, this length here, divided by its opposite angle, DAC, equals AC, so this length here, divided by ADC, this opposite angle here. And so if we fill in all the information that we already know, we can see we've only got one unknown, which is great. So if we multiply both sides by sine of 12.832 ... we'll get the length DC, which is what we want to work out, equals this on the right hand side. And if we just pop it into the calculator, we get that the length DC equals 1.95035 ... And our final step is, because it said it wants it in 3 significant figures, we're going to get 1.95 centimetres to 3 significant figures, if I can just about fit it in the answer box there. Fantastic, so this is quite a long question, so we get 5 marks in total. We got our first mark for substituting into the cosine rule. Second mark for getting down to work out what the angle C is. Third mark for starting to use the sine rule and substituting into it. The fourth mark for working out and rearranging it. And the fifth and final mark if we got the correct answer to 3 significant figures.